Good day. So in this lesson, we will be discussing the concept of Kirchhoff's law. So there are actually two particular laws that we are interested in, the Kirchhoff's voltage law and the Kirchhoff's current law. In the previous lessons, we have already considered the concept of Ohm's law and how we can use that particular law in analyzing the circuit and calculating parameters such as voltage, current, and resistance. So we also considered the concept of series and parallel connected networks, as well as those of Y and delta connections. However, there are some cases wherein Ohm's law and such methods are not enough. So we will be also using this particular laws in order to aid us in calculating or analyzing complicated networks involved in circuit analysis. So before we dig deeper on the KCL and KVL, we have to first look into the concept of some basic parameters that we need to be familiar with in using these particular laws. By the way, this particular law was introduced by Gustav Robert Kirchhoff. So there are things that we need to consider first. We have the branches, the nodes, as well as the loops. So first, we have to define all of this in order for us to analyze and use the KCL and KVL. So consider this network shown here. We are to determine how many branches or which part of this network is called a branch. So basically, branches is any single element component of the network. So in this case, we have the 10 volts as one component, the 5 ohm, the 2 ohm, the 3 ohm, the 4 ohm, as well as the 2 amperes. For this particular network, we have 5 branches. Please take note that branches need not to be an active element. It could be an active element or a passive element. It could be in series or parallel. So if we just count the number of elements in the circuit or in the network, then that is the number of branches. Now we consider the number of nodes. So nodes is a point of connection between two or more branches. So in this particular network shown, we have 3 nodes, the A, the B, and the node C. Please take note that node B is, though it is separated in our drawing into 3 points, it is just one node because there's no branches in between the 3 nodes above. In the same way, sa ilalim, we simply have one node or for node C because wala namang elements na ibang nakalagay sa ilalim natin. So finally, we can consider the loops. Loops is any closed path in your network. So if we are to trace a path in the network, if tuloy-tuloy yung path na yon, then that is a loop kasi dapat closed path siya. So in this case, we have 3 inner loops. We have the blue one, and we have the another 3 that passes through or bypasses certain branches. So in other words, in this particular network, we have 6 loops. However, we are also interested in defining dependent as well as independent. So when we say dependent loops, it means that it doesn't have a branch that is unique to itself. In case of independent loops, it simply means that those loops have unique or independent branch or element in it. Ibig sabihin, ang meron siyang element na hindi present sa ibang loops natin. So please take note of that because in KCL and KVL, we are more interested in the independent loops rather than the dependent loops. Okay, so let's try this particular problem. We have 2 networks shown. Are asked to identify the branches, the number of branches, the number of nodes, and the number of independent loops. Okay, so please try this one. Pause the video and try to analyze the circuit and identify the number of branches, nodes, independent loops. Okay, so if you are done, let us now try to discover what are the answers to this question. So for the network above, the 10 volt, the 5 ohm, 6 ohm, the 2 ampere source, we can identify, say, we will be having a total of 4, right? So 4 branches because we have 4 elements. So simple lang, we just count the number of elements in the circuit or in the network, and that is the number of branches. So we have 4. For the number of nodes, we just have to identify that. So we have one in between 10 volts and 5 ohm, another one, the connection of the 5 ohm, 6 ohm, and the 2 ampere source, and of course, sa ilalim, which is the connection of the 10 volt, the 6 ohm, and the 2 amperes. In other words, we have 3 nodes. For the loop, independent loops, for independent loops, it's always good to just look at the inner loops. So that is basically the number of loops that you are interested in. So in this case, we have two inner loops. So therefore, the answer is 2. For this particular network, we have 4 branches, 3 nodes, and 2 independent loops. Okay, now for the second network, we will just follow the same procedure. So we have for the number of branches, 5. We have for the number of nodes, we can identify 3, 2 sa taas and isa sa ilalim. And finally, for the number of loops, we can easily see that it has 3 loops. Okay, so I hope that you got it right. And now we are ready to proceed since we can now identify the number of branches, nodes, independent loops. In the next part of this video, we can use the KVL and KCL in order to analyze the circuit. Okay, so see you at the discussion on Kirchhoff's voltage law.